we wanted to firstly find out why in Qlik Sense load balancing is required and very important. To start, I would like everyone think about one typical situation. So imagine one company wanted to decide to implement our Qlik Sense software. So initially, they wanted to start using this from one or few departments. So that means they will have less amount concurrent user session, and they will have a less amount of apps. With less concurrent user session, that means we have less proxy workload. And with less apps, that means we have less engine workload on the visualization. Also, with at the starting, when there are not many apps, so that means the tasks amount also is less. So quite often, when we start this single node deployment, this scheduler task can be quite comfortably to be scheduled at off business hours. So that means the workload for the task for the scheduler is not heavy as well. For this type of business requirement, we are quite comfortable to have single node deployment, because this can accommodate all this workload. Specifically, we split the engine workload and the scheduler workload into business hours and off business hours. Next, after half a year, this company's business increased a lot. And with the experience on Qlik Sense, they realize the Qlik Sense visualization has helped them dramatically on the business analysis. Now they decide to implement Qlik Sense on all the departments. What does that mean? That means they're going to have a higher number of concurrent user sessions on Qlik Sense, and they're going to have a large amount of concurrent app reload as well. So that means the proxy and engine node workload increasing, and the scheduler workload also increase a lot, increase heavily. With the business transaction data keep increasing, each visualization app data set also keep increasing. This absolutely create the heavy workload on engine node and the scheduler. So for all, the current system workload increase triple or maybe 4 times higher. To analyze the business from different angle, then the analytics requirement also keep changing and increasing. We have seen some companies' apps even increase the very complex analytics methods and the very complex dashboard. So all these are becoming challenge for the current single node deployment. So it's time for us to review the current single node architecture, whether it is still can be able to help on our business. Besides, there are, for any production environment, there are certain deployment requirements. First, for the production, we definitely need to provide the high availability and resilience. That means the production system should always keep the user connection consistent and task reload consistent. It doesn't matter any Qlik Sense service or the server is down. Secondly, we always like to maintain a standard or even higher standard performance for the user visualization and also task reload. So how to improve? Definitely, we need to think about the architecture. We may need to think about to increase the hardware power. And also very important, we need to think about how to distribute the workload. The workload, if it's not distributed evenly, then it definitely will impact the performance and the server resource consumption. So in order to distribute workload, we definitely need to have multi-node deployment. With multi-node server in the system, we will be able to optimize the resource utilization. We will be able to allocate the dedicated resource for the certain specific tasks. For instance, the customer quite often like to dedicate the development resource for the development task. We also would like to allocate the dedicated scheduler resource for the task reload. So by considering all these challenges and deployment requirement, it's time for the company to revise the architecture design and think what is the best deployment to meet their requirement. When we talk about multi-node deployment, very important thing is we need to be clearly design the function for each node in the whole architecture. So here I would like to introduce some concept. Based on the node function, we would like to define the nodes as consumer node, developer node, scheduler node, and central node. So what does each node function mean? For consumer node, mainly consumer node will support to create, mainly consumer node is used to create the user proxy connection, and also will be used to allocate the workload to different engines. So that's why you can say consumer node has proxy service and engine service. Developer node, we all know for developer, what they do is every day they will create app, update the app, and when they are doing testing, they need to manually reload. So all these activities actually will be happen on engine node. So all these transactions will create a lot of workload on proxy and engine. We do not want this development works interfere our production end users visualization activity. So we really need to separate to have a dedicated developer node for development work. Scheduler node is mainly for the task reload. So scheduler node, you can see we have scheduler service, engine service, but no proxy service because scheduler node is not for end user to build the session. Central node is a must scheduler and is where we wanted to access QNC. So this very important. I would like to, so whenever we design multi-nodes, we should always think about this concept. Now I want to, there are many different architecture to meet different business requirements. So here I just pick one typical deployment architecture as our example, and all the further coming demonstration will be based on this example as well. So here we can see when we look at this architecture, we can see we have 2 consumer nodes, we have 2 scheduler nodes, we have dedicated repository service and file server system. So this architecture definitely provides the high availability. To see that, we can explain why. So first of all, we have 2 consumer nodes. With these 2 proxy service, we will be able to make sure in case any proxy is down, then another proxy will be able to pick up the user's request from network load balancer. And also with 2 active proxy service, the workload of the user sessions will be shared. We have 2 empty nodes, and then all the visualization workload also will be shared. This will be able to optimize the engine resource to improve the visualization performance. So we have 2 scheduler nodes. Here we have 1 central node, and we also have 1 failover candidate. So that means even the central node is down, then the failover candidate will be able to pick up after 5 minutes. Because this is the failover, it has all 5 services, so it's sleeve scheduled as well. So with this architecture, we make sure we have central node failover. We also make sure we have 2 scheduler nodes to be able to share the task reload. So this also creates the high availability and better performance. With the dedicated repository server, we will be able to make sure, ensure the high availability. The reason is if we have the same repository service in the central node, if central node is down, then the whole system will be down. Okay, so this is just roughly explanation about how good to have multi-node deployment, and then we will be based on this, we will explain how exactly Qlik Sense load balancing work in the multi-node deployment. Okay, so there are different layers for the load balancing. First layer is network load balancing. Network load balancing also play very important role in Qlik Sense. So this network load balancer is a third-party load balancer. It's not a Qlik product, but it helps to balance the workload of proxy sessions. There are 3 jobs this network load balancer can do for Qlik Sense, or for Qlik Sense. So firstly, we do not want to expose Qlik Sense server URL to the end user for the security reason. So we will only expose the load balancer URL to end user. Secondly, the network load balancer has its own algorithm to be able to allocate the workload evenly among Qlik Sense proxy nodes. So this will be able to help on the high availability and the better performance. The third part is the network load balancer also does a health check on the proxy. So if it found one proxy is down, then it automatically will allocate all the future session to another proxy. So this ensures the user always be able to access Qlik Sense. In order to make network load balancer work with Qlik Sense, very important. There are certain setup, but here I just want to mention WebSocket is very important to be enabled on load balancer. And also the timeout on load balancer need to be aligned for HTTP and WebSocket as well. So next layer is Qlik Sense proxy service load balancer. This is where Qlik Sense load balancer started working. Okay, so this is a proxy service load balancer. Obviously, it is performed by Qlik Sense proxy services. That means whenever the user from load balancer connected to Qlik Sense proxy, any proxy service, then the proxy take in charge to allocate the workload to any of this engine node. By default, proxy service is using round-robin algorithm to allocate the engine session. For instance, user A connected to proxy, and this proxy to engine 1. And when user B come to the proxy, connected to proxy, and the proxy will allocate the session to engine 2. Then when user C connected to proxy, then the session will be allocated to engine 1 again. So this is the round-robin service, round-robin algorithm. We also provide the flexibility for our customers to create the advanced load balancing to change the behavior. So for that we need to create the load balancing rules. The third layer is scheduler load balancing. So the scheduler load balancing is performed by master scheduler, which is the central node. So central node can be master scheduler or master and sleep scheduler. Master scheduler always decide which sleep scheduler node the task reload should happen. Scheduler also has its own algorithm to evenly allocate the task reload workload on the sleep scheduler node. So for Qlik Sense November 2019 and earlier version, the algorithm is to select a sleep node with lowest CPU load. But this this algorithm has been changed from February 2020 and the later version, and this has improved the performance a lot. With this, with this new algorithm, we found that the task reload on the scheduler, it has been balanced much better, and the performance also improved a lot. So the new algorithm is master scheduler will select the sleeper node with fewest running task. So this is the recommended way to run the scheduler load balancing. We do not recommend to change this behavior. Okay, so I think by now you all should be much clear about how our Qlik Sense load balancing works. But in reality, how exactly it works, I would like to show you some example, how we set up. I think that will give you much better idea. Here I have two practice. So one, we want to isolate the developer node from the consumer node. As mentioned earlier, the developer, they have a lot of activity by creating, updating app and manually reload the apps. And this activity create the heavy transaction. We do not want developers' activity to impact our end users' visualization. So we need to separate to have a dedicated development node for development job. So to do that, we would like to have all the development job on the development node. We also would like to have all the published app. That means when the end user open any published app on the consumer node, it should only go to consumer node. Development node only for development job. Consumer node only for the consumer visualization. Before we do setup, we wanted to review our default multi-nodes environment configuration. So this is by default after you install the multi-node environment. We have central node, fill over candidate, also is a scheduler node. We have 2 consumer node. We have 1 development node. And all these 3 nodes do not have scheduler services. By default, there are 2 load balancing rules. So why we mention load balancing rule? Because if we want to create the advanced load balancing, we have to utilize the load balancing rule to change the behavior. By default, we have load balancing rule for central node. That means on central node, the admin will be able to see everything, and also will be able to do everything, visualization and task reload. And another load balancing rule is for all non-central node, means rim node. So by default, for all rim node, the user should be able to see all the apps except monitoring app. If you want to change this behavior, then we have to disable this load balancing rule for non-central node. So now, to start our exercise, we already disabled this non-central node load balancing. Scenario 1 is we want to have all the development job happen, be allocated on the development node only. Okay, so when in our system, how we can get to know which node is for what, which function? It's just not just by the name. We really need to use customer property. We can use customer property to identify. So the name is just a name, but truly is a customer property, where is the one to help you identify each node function. So here we create a node type customer property, and we give 3 values: development, scheduler, and consumer. So we have consumer node 1, consumer node 2, development node, central node, and fill over. What we want to achieve, so we want all the unpublished or all the development job goes to development node only, which is this node. Well, in my test is a Qlik server client. So developer only can work on all unpublished app, because all published app will not be able to be editable. So now, first thing, we need to create a customer property. Node type is a customer property, and we link to the nodes. We create 3 values to identify each node function. Now, when we come back to QMC nodes, we will be able to say all these nodes has been defined via customer property node type. So we are very clear, this is the development node, and we want to allocate the development job. To create the advanced load balancing, we need to add all those nodes which we want to load balance the workload into the virtual proxy. We always recommend to do not change the default virtual proxy. Instead, create your own virtual proxy. So here we will create one customer virtual proxy for this practice. So we have this one virtual proxy and added all these 3 green nodes to do load balancing. Next, we need to create the load balancing rule. So in this load balancing rule, you can see we need to select the load balancing. We also need to create this load balancing rule. From here, we can see how we can define the app is unpublished. So if the app stream is empty, that means it's not published. So we want to open this all unpublished app to the node tab equal to development. Once we create this load balance rule, we need to check whether this rule has been meet our requirement. So here at the bottom there is a preview button. I just forgot to take this screenshot. So there is a preview button. Once you click a preview button, it will bring up the result in this audit section to let you know whether this is what you are looking for. So here we can see for development node, we can see 1, 2, 3, 4 apps. So we can assume there should be 4 unpublished apps. Another thing, before we go to check, we want to make sure because in Qlik Sense, you can create multiple load balancing rule. And after you create all these load balancing rule, these all will be taken into the consideration when you work on the visualization. So we can't only look at this one individual load balancing rule because other load balancing rule can change the behavior. So how to check that part? We need to click this audit. This audit button in the audit section. Then we can confirm whether the result is still same or have been changed by other load balancing rule. So here we can see still there are 4 unpublished apps. Okay, so this is what we are looking for. Now let's go to check how many unpublished apps we have. We can see here we have 4 in total. That's perfect. So what we have, what rule we have created, it meets the reality. Okay, so now let's do the last step to do some testing to confirm whether it works perfectly or not. In this test, I have user 1 and user 2. So I use user 1 and user 2, log into consumer node 1 and 2 and the development node. And then I create user 1, create a new app, and the same for user 2. Then we will create the new app and also open the app. So these 2 apps are staying in the work stream, is unpublished. So after you did this test, then how to check where the session has been allocated? We can utilize a monitoring app. We have multiple monitoring apps, but in this demonstration, I just picked this session monitoring app. So basically, the monitoring app will fetch the data from archive log and active log. So if you want this monitoring app to be able to pick the current active log, you need to reload the session monitor. So now we have reloaded the session monitor, and we suppose to be able to see the rim node session detail as well. Now let's say we only want to look at unpublished app activity. Firstly, we will go to the string and select unpublished. And then we can create the filter like last 4 hours, or if you know exact hour, date, session duration, you can also make this filter. And just now we used 1 or 2, so we want to create another filter. Here I just want to show you some other way easily help you to do the visualization. You can select administrator and create these triple dots, then select excluded. Then automatically it will exclude the administrator and select user 1 and 2. Now we only look at last 4 hours, user 1 and 2 for all unpublished activity, session activity. So this is the engine session. We can see all these engine session already goes to host name Qlik server 5, which is my development node. Okay. The next task is we want to have all published app be opened on consumer nodes. So by this, after finishing this, we will be able to separate the development work and the end user visualization work on development node and consumer node. So let's again look at this architecture. Same thing, how we define it's a consumer node, we need to use node type. And then what we want to achieve, we want all the end users visualization for published app only goes to consumer nodes, which is consumer node 1 and 2 engine service. So for instance, the connection allocated to consumer node 1 proxy, then this proxy will take in charge to decide which engine the work will be allocated. It only can go to consumer node 1 engine service or consumer node 2 engine service. Same thing, if consumer node 2 proxy has connected the user session, then consumer node 2 proxy will take in charge to decide which engine service will start working on this visualization work. Either consumer node 1 engine service or consumer node 2 engine service. So this is our goal. Now we need to create this load balancing rule to achieve this task. We create this load balancing rule to identify the apps is published. The way is the string, the app string is not empty. So app string is not empty, and then it will be opened on node type consumer. Now let's again click the preview button to check this individual load balancing rule, whether it works as what we expect, as we set up. So here we can see consumer node 1 and 2 supposed to be only see 1, 2, 3, 4, 5, 6, 7, 8, 9 published apps. So same thing, I just forgot to take that screenshot. Same thing, we need to check the audit in the audit section, because this is how you can take other load balancing rule into the consideration as well. That is the final result to see if your load balancing rule has been set up successfully. So in my case, that result is the same. Now I again go back to my apps to see how many published apps I have. I have 1, 2, 3, I have 1, 2, 3, 4 here. So I have 9 apps. So that's again works as what I expected. Now, last step is again I need to do testing and check the session monitor log. Session monitoring app. So in this test, I have user 1 login, consumer node 1 and 2, and the development node. Then open the published app. I have 2 published app. In this test, I open these 2 published app, and the same for user 2. After this, I reload the session. Then I will check, create the filter. So in my case, the data is not large, but in the production environment, all this data will be huge. So creating filter, how to use this filter, this really can help you to improve the productivity. So we wanted to, again, same thing as I mentioned, we will look at the last 4 hours firstly, and we will look at all the published app. So this is my selection for published app. And I will exclude the administrator user from my user selection. Then I will go to host name to see how many host name has my session and what are the hosts. So we can say Qlik server 3 and 4. Okay, that is what we want. We only want the published app to be open on server 4, 3, and 4, which is consumer 1 and consumer 2. Okay, so often I see at the customers' Qlik Sense server side, they always have some large apps with large data set and complex analysis setup. So quite often, the customer log the case saying the performance get impacted by the large app. So it's quite necessary in some situation we need to allocate this type of large app to the dedicated engine. How to do that? Okay, so this is what we want to achieve. In this example, we want to allocate one or few specific large app only to consumer node 1. This is just my example. And all small app will go to consumer 2. And so same thing, it doesn't matter which proxy I connect, but both proxy service should only allocate the session to the workload on customer node 1 engine service. Yeah, so this is what we wanted to achieve. To do that, we need to create another customer property. Here we have engine group, and we use engine group link apps and nodes. So we assign the customer property value to the apps and to the nodes. So you can have multiple customer property for different load balancing or security rule purpose. So this is my load balancing rule to allocate the specific apps to a specific node. So here you can see I have engine, if node engine group value equal to the app engine group value, then that app will be opened on this node only. So let's check the result. I can see customer node 1 only can see this one large apps. So this is I have made a very simple demonstration, just show you how it works. Again, I need to check in the auditor section by considering all other load balancing rule as well, make sure the result is identical. Okay, I'm quite happy with this setup. Now, let me do the test. So I'm using user 2 and user 3 log into consumer node 1, 2, and development node. Then open this published with large apps. Then I reload the session monitoring app. Again, I set up the filter for last 4 hours. I select this published app, and I will look at host name to see which which node this session has been allocated. It only show up Qlik server 3, which is my consumer node 1. So it's very good result. It's expected, and I'm quite happy about this. Okay, so this is the session. I can see I have engine session for user 2, engine session for user 3, and both are allocated on Qlik server 3. Okay, so this demonstration, I think, I wish is clear for you all. And if you have any question, feel free to ask. At last, I wanted to mention, if you want to use monitoring app to check the result for a multi-node environment, you need to do the configuration. So we have a available article in support portal. We also have a complete, very detailed document in Qlik help site. So you can check that configuration. Here, I just wanted to mention 2 things. One, if you have login database, you have option to decide whether the monitoring app you wanted to check load the log from login database or from the logs file only, or from both. So in my test, I just disable, and I only wanted to load from the file logs. And this is very necessary. You need to make sure all the active log file or log folder on the read nodes to be shared with a service account. And also you need to add these log folders in the log folder list in the monitoring app. So for all the monitoring app, this is configuration need to do. Okay, so here we have some link you can, and we have so many available articles. I think my time is a little bit over. I want to give some time for the Q&A session. Okay, thank you. And anyone has a question? Yeah, please feel free to ask. Okay, so there is one question. The customer is, sorry, the question is, in an environment without external network load balancer, the users will need to be segregated by proxy URL. In this case, will the configuration be the same as with NLB? Qlik Sense configuration will be the same, but if you do not have a network load balancer, then you will need to, then the proxy session will not be able to be shared. So you have either you need to provide individual proxy URL to the user, or if you only provide one virtual proxy, then that virtual proxy will not be able to achieve the same as a network load balancer. I wish that is clear. Any other question? Another question is, if I have central and fill over, then central went down, master scheduler, which resides within the central, went down too. How do automatically switch fill over as master scheduler? Okay, so this is automatically be done if you have the fill over candidate, then the fill over candidate automatically will be picked up and be changed to master scheduler after 5 minutes. So this will be automatically done. Any other question? Okay, so another question is how can we know when we need mult-node? I think the example just now I have bring up initially that is a single node. So, but when you use that single node, 1 second, go back. Okay, so with this one single node deployment, this can only accommodate some limit concurrent user session and limit the task reload. So with just now I have mentioned, so when your business when the business requirement increased, you will one day you will realize you need to have a large amount of concurrent user session and app reload. So you will be able on the current single node deployment, then you will be able to experience maybe performance issue, and also you found the current resource consumption is not evenly, and sometimes impact the whole system performance quite largely. At that situation, then what we normally recommend is to look at that particular time what happened. So for that, you can review this monitoring log to see which app is opening, which task reload is opening, is happening. Then you will get to know whether there's some resource conflict. And if you have so many tasks which have to be reloaded during business hours, and your visualization also at that time happening, and the concurrent visualization session amount is also large, then definitely there is a resource conflict. Then in this case, there is no option. We need to think about the multi-node deployment. Okay. Sorry, there are many questions. Is there any way to shorten 5 minutes time for the fill over to take a master scheduler? I don't think so, but I don't think so. Yeah. Yeah, I can confirm this part and get back to you later on. The reason is we need to give central node the time to release the session, and also give the fill over candidate to be able to take over all this resource. and also the configuration, internal configuration changed. The failover candidate become master node and a master scheduler. So all this take time. If very limited time, so 5 minutes, we will be able to make sure all this will be set up correctly. Another question. 1 second. There is a question in the multi-node deployment. Can you also talk about the certificate setup? Qlik Sense nodes will deploy its own certificates. How about local network certificates for the virtual proxy? So for Qlik Sense nodes, a central node has its own self-signed or third-party certificate, and this certificate will be distributed to all the ring nodes. So this is very clear. I think the question here is the certificate for the local network certificate. This certificate, my understanding is this certificate doesn't need to be assigned for Qlik Sense virtual proxy. It's only the certificate for the network load balancer, and that should be the separate. Yeah, but again, I can confirm this. Yeah, I can again confirm this part later on. Compare single node. This is a bigger question. If we set up multi-nodes, how much percentage of performance we can improve when compared to the single node? This is quite a big question. Actually, for the multi-nodes deployment, that is a very big topic. There are many different ways to set up the multi-node environment. It's even though, like here we have deployment challenge, we have deployment. This is coming from the business requirement, and we have deployment requirement. This is for the production system, the deployment side. We need to make sure the system work with high availability and high performance and stability. So, but still, when we set up, when we design the architecture, we need to prioritize all these requirements and the challenge. That's why I said the deployment is a big topic. The same requirement, there are different priority. Then the architecture will be different. Then architecture different, the performance improved also will be different. Yeah, and also user amount, the app data set size, all this it's hard to say. Yeah, only if you have different development environment, you can do some testing, do some different setup, and with your own requirement and the data set, you can do some testing to find out how much percentage with different architecture design, the improvement, what is the difference of the improvement. Yeah, okay, I think that's all question. Yeah, that's all question so far. Yes, so you need to check the monitoring app log. By default, we only have, after you install Qlik Sense, you will see license monitoring app and operation monitoring app already installed. for other session monitoring app, reload monitoring app, and others you need to import. It's already available. Yeah, you just need to import into the QMC. Yeah, the recording will be available, and we will deliver an article with the recording link. Yep. Any other question? Okay, you're all very welcome. I wish this information is delivered clearly, but if you have any question, yeah, you feel free to log the support case, and we are very happy to, yeah, to discuss in more details.
Okay, thank you very much, Lisa. I think this will end the session for today. Thank you all for joining.
Thank you all.